Hi everyone and welcome back to a new episode of BWD. Today we're gonna code a program to roll as many dice as we want. Each dice is gonna be displayed next to each other. When there are too many, they are gonna be displayed over multiple rows. And finally, there's gonna be no limit. You will be able to roll as many as you want. If you are new to this channel or you're back watching this video, do not forget you can find timestamps in the description below. And all the code that you're gonna see in this episode is available on GitHub. Just look for the project repo. Link in the description below. And now, without further ado, let's get started. Before jumping straight into coding, let's have a look at the board to make sure that we fully understand how the program is gonna work. As a first step, we're gonna ask to the user how many dice to roll. Next, we're gonna generate the result for each dice. And finally, we're gonna display all of them. Pretty simple, right? However, keep it in mind that this is expected to work in three scenarios. In the first one, the number of dice will be not enough to fill a full row, whereas in the second one, they're gonna be just right. In the third scenario, the number of dice won't fit in one single row, so they're gonna be displayed over many. And now, let's make a few examples to visualize each scenario. Let's suppose that your computer screen is gonna be wide enough to have at maximum 8 dice displayed per row. This entails that if the user types in any number lower than 8, then we're gonna be in the first scenario. So for example, let's say that a user types in 3. Then this is what we're gonna see at the screen. Whenever instead the user types in 8, then a full row is gonna be displayed. And finally, anytime the user is gonna go higher than that, then we're gonna get multiple rows. Great, hopefully we are on the same page and now it's time for coding this. Let's start by step number 1. Here we're gonna ask to the user how many dice to roll. To do that, we're gonna use the input function and assign the result to a variable. Next, at step number 2, we have to simulate each roll and save the result somewhere. First, let's assign an empty list to a variable called rolls. This is gonna be in charge of keeping all the results. Next, we're gonna define a for loop. And to generate the elements we're gonna cycling over, we're gonna use the range function. If you don't remember or you just don't know how this works, just check out episode number 2 of this series, where we've explained in detail how this function works. Okay, back to our for loop now. At each iteration, we're gonna assign the result of the simulation to the roll variable. However, we're gonna see in a few seconds how to do that, so let's just leave it as a question mark for now. Finally, we're gonna save each result into the rolls variable. And to do that, we're gonna use the append method, which let us add a new element to an existing list. Okay, great. And now here comes the question. How can we simulate a dice roll? Well, the answer is pretty easy. Simulating a roll dice is equivalent to generate a random number. And as we've seen in episode number 1 of this series, to do that, we can leverage the random module. So exactly like episode number 1, we're gonna import a random module and use the randint function. This let us generate a random number, and using it is really easy. We have just to specify the lowest and the highest possible number. Great! And now, before moving to the next step, let's just pay close attention to the very first line where we define the for loop. As you can see here, there is a new element that we have never seen in the series before, and this is the cycling variable, or in other words, the variable that we use to store the element that we are cycling over. In the previous episode, we have always used either a word or a character of the alphabet. However, this time we're doing things differently, and specifically we're using the underscore character. So why this choice? Well, the answer is pretty easy. There is no rule in Python about what you should choose as your cycling variable. However, there exists a set of guidelines to write Python code. And these were created with the idea to make your life easier when you're reading code written by another developer. Specifically, if you pick up underscore as your cycling variable, then you're letting other people know that the cycling variable is not used anywhere else in your for loop. The point here is that whoever reads the code and see a cycling variable never used in the cycle might be confused about it. In fact, they may think that either this is right or the developer made a mistake. And an easy way to clear this out is to use the underscore as a cycling variable. In this way, you're letting know whoever reads the code that this was done on purpose. Okay, great. Hopefully this is clear. If not, let me know in the comment section below. Okay, now before moving ahead, let me open a Python interactive shell in the window below, and let's focus on the code written to get step number 2 done. As you can see, the number of lines is not too high. However, we are still getting down one single task. So the question is, can we do better than this? Are we able to reduce the number of lines ideally to 1? Well, the answer is yes, we can. Exactly like we've done with dictionaries in episode number 3, we can reduce all this code to a one-liner. And the syntax that we're gonna use to get this done is called list comprehension. As you can see, we're not assigning an empty list to the roles variable anymore, but instead we are writing the for loop between square brackets. And now, if we check what's in the roles variable, we're gonna find the result of each simulation. So as you can see, with just one liner, we are able to get step number 2 done. And the best part of it is that now our code is definitely more readable. Don't you agree? I think it's way better this way. Okay, it's time to give it a try to our code. Ouch, something went wrong. As we can read from the error message, Python complains that we are passing a string rather than an integer to the randint function. So you might be confused and say, well, but we are passing an integer. The user is typing in the number of rows, right? But actually we are not. Python is right about it. That's because the input function does not return a number but rather a string. So to get this fixed, we have to apply the int function to the return value of the input function. And this has to be done before assigning it to the n_roles variable. Great! As you can see, our program does not break anymore now. Back to our code, let's move ahead with step number 3. Here we're gonna write down another for loop and cycling over all the roles. At each iteration, we're gonna have to generate and display the dice phase for each role. But how can we do that? An easy way to go about this will be to define a dictionary. And let's call this phases. Each key is gonna be the number that we can read on the dice phase. 1, 2, 3, and so on. And the values are gonna be the images that we're gonna display. As we can see, images are defined as strings, but they are spread across multiple lines. And to create a string like this in Python, you have to use triple quotes. And now displaying the dice phase for each role is pretty easy. We have simply to pass to the phase dictionary the value held in the role variable. Let's give it a try. Let's take things easy. We're gonna go with only 3 dices this time. And here we go, we got 6, 4 and 3. So we definitely got this working, but the output is not what we really want, right? As we can see, dices are not displayed next to each other. Instead, we would like to have something like this. Way better, right? So let's see how we can get this done. To display a single dice phase, we have seen that we can just pass the role variable to the phases dictionary and then print the image that we get out of it. And this works because we have saved the image as a string within the dictionary. However, this is not the only way that we can go about this. An alternative is still to use the phases dictionary, but not save the image as a string, but rather as a list. Here, we're gonna cut the image into lines, and each line is gonna be an element of the list. So for example, the first element is gonna be line 0, the second is gonna be line number 1, and so on. So now you may wonder, why are you calling the first element line 0 and not line number 1? That's because in Python, when we refer to the element position in a list, we don't count from 1, but rather from 0. And to avoid confusion, we also name elements in this way. Now, to display a dice phase, we cannot go as before. When we call the phase dictionary this time, we don't get the image, but rather all the lines. That's why we're gonna write down a for loop cycling over the lines, and at each iteration we're gonna display the new line. In this way, we're gonna get the same result as before. So now you may ask, what is the advantage of displaying the dice phases in this way? Well, if we have to display just one dice phase, there is no advantage at all. On the other hand, if we have to display multiple phases and we want each of them next to each other, this approach will help us to get things done. Let's go back to our previous example where we have 3 dices, 6, 4 and 3. To display all of them next to each other, we can think of doing this in this way. First, we're gonna take line 0 of the first dice and display it. Next, we're gonna do exactly the same for the second and the third dice. Right after, on the line below, we're gonna do exactly the same thing but for line number 1. So in practice, we're gonna keep doing this till there are no lines left. At that point, we're gonna have display each dice phase next to each other. And now let's see how we can get this done in Python. We're gonna define the row variable as an empty string. This will be in charge to hold all the lines that we're gonna display. Next, we're gonna write down a for loop to iterate over each line. And within it, we're gonna define another for loop to iterate over each role. Every time we're gonna add to the row variable the corresponding line for each role. However, we must not forget that between the phases there's gonna be a little bit of space. That's why before moving to the next role, we're gonna add to the row variable an empty string. Then, when we exit from the second for loop, we have also to add a new line character to the row variable. That's because every time that we get out from the second for loop, we are moving to the next line. However, we have to tell Python the next line has to be displayed below the current one. And as we've seen in episode number 2 of this series, the new line character allows us to get this done. Finally, when we get out of the first cycle, we're gonna display the content of the row variable. Okay, great. I hope this is clear. If not, let me know in the comment section below. And now, let's code and try this out. So as you can see, the Faces dictionary contains the changes that we have just showcased a few seconds ago. Next, let's move ahead refactoring step number 3. As you can see, the only difference with the code that we've just seen is that we don't have the row variable anymore, but rather the result variable. Let's give it a try. And great, we got this working. Let's give it a try with more dices now. If we go with 8, as you can see, we fill an entire row. But what happens if we try with 9? As you can see, we didn't get the expected output. This means that our code works, but is not able to handle scenario number 3. Any idea? Well, let's go back to the board and see how we can sort this out. Let's suppose to have 18 dices. And as you can see, because of the screen size, these are going to be displayed across 3 rows. The idea to get this done is pretty easy. If we knew the total number of dices that we can display per row, then we would be able to take all the dices, split them in groups, and assign each group to a new row. So let's see how we can compute the maximum number of dices per row. This is going to be equal to the ratio between the screen width and the face one. However, we must not forget there's going to be empty space between 2 faces. That's why we have also to sum that up. Back to coding, let's import the math and US module. We're going to use them right away. Next, let's define the screen width variable. To get this value, we can use the getTerminalSize function from the US module. And if you don't know how this works, just check out episode number 2 of this series. Right below, we're gonna compute the maximum number of dices per row, applying the formula that we have just seen. And we're gonna write down 11 for the face width and 1 for the empty space. So a good question now will be, how do you come up with these numbers? That's pretty easy. The screen width is measured in column, and 1 column is equal to 1 character. So what I've done was to count how many characters are found in the face line, whereas for the empty space that is even easier. In fact, we know that we are just adding 1 empty space. 1 empty space equals 1 character. Finally, we're gonna compute the total number of rows needed to display all the dice. And this is pretty easy. It's just the ratio between the number of rows and the maximum number of dices per row. Now let me open a Python shell in the window below, so I can show you that these formulas don't always work. Suppose to have a screen width of 144. If we then compute the maximum number of dices, this is gonna be equal to 12. Suppose then to have 30 rows in total, then we're gonna need 3 rows, but instead, with our calculation, we're gonna get 2.5. Not really great, right? But this doesn't stop here. Suppose now that the screen width is equal to 134 instead. If we try to compute the maximum number of dices per row again, we get 11.166666. This means that we can display up to 11 dices per row, and then there's gonna be some place left over, but that is not enough for another dice. To get out of this formula 11 instead, we need to import the math module, and from this one we're gonna use the floor function. As you can see, we got exactly 11, and that's because the floor function drops the decimal part of any number, and this is exactly what we want. Now, to compute the number of rows needed, we're gonna use another function called ceil, which rounds up any number with a decimal part to the next integer. So for example here, the ratio is equal to 2.72 and blah blah blah. By applying the ceil function, we're gonna get 3. Great, and now let's fix our formulas with these functions. Now let's put the code below into a for loop where we're gonna iterate over the total number of rows that we need to display. However, the code written this way is not gonna work. That's because in the third for loop we're cycling over all the rows. But that's wrong, because we should get out of it only the rows assigned to the row that we are displaying at the current iteration. Let's go back to the board now to see how we can get this done. If we consider the example that we just seen a few seconds ago, we're gonna have 3 rows in total. So to get the rows assigned to each row, we have to play around with their position. For example, for row 0, we're gonna have to take all the elements from position 0 up to position 6 included. For the next one, we're gonna take all the elements from position 7 up to 13th. And finally, for the next one, for 14th to 17th. So here what we are doing, we're just specifying the first and the very last element. Pretty easy, right? However, we can do even better. In fact, if we remember the maximum number of dices per row, then there is no need to specify also the last element. What we can do instead is, for row 0, take all the elements from position 0 up to position 7, but this is not going to be included. And the same thing is going to work also for row 1. And finally, for row 2, we're going to just take what's left. I hope this is clear. If not, don't worry, because right now we're going to code this and it's going to get even easier to understand. Let's start by defining the position of the first element of each row's group. This is going to be equal between the product of the maximum number of dices and the current row number. Then we're going to compute the first element of the next row. And to get this, we have just to add the maximum number of dices to the position of the first element. And now we're finally able to get only the dices that we should display at the current row. To do this, we're going to use the following syntax. We're going to write between square brackets the two variables that we have just defined, but separated by semicolon. What we have just written is also called list slicing. And now let's give it a try to see if this works or not. Let's start with only 3 dices. Now let's try scenario number 3. And here we go, everything seems to work. And now let's try with even more. And here we go, we got the job done. Okay, we have finally come to the end of this video. If you have any question or feedback, just write it down in the comment section below. Do not forget to give it a like and subscribe to the channel to not miss next week's episode. In the meantime, if you want to do more, just check the GitHub repo where you can find the next steps for this exercise. And with that said, see you in the next one. Ciao!